Hi, I'm Sportster Paul. Back in 1980, I worked at Ford Light Truck Engineering on the 1980 pickup truck. Actually, 1977 I started working there, and was involved in an engineering disaster. They changed the instrument panel from steel with plastic cluster to a big giant piece of plastic. It was sold as a cost reduction, but the real thing is the stylists wanted it all plastic so they could make it pretty, and they carved it in clay, and you can hot stamp plastic with chrome and have free chrome, cheap chrome. So that's how it was sold. By the time we were done, it was a cost penalty, durability problem, reliability problem, and worse yet, it would kill you when your head bounced off the plastic. Steel panel, when you hit it with foam over it, the foam protects your head, dents the steel, absorbs the energy, and doesn't kill you. So let's go piece by piece how this disaster unfolded when I was at Ford. Okay, for context, the 1980 pickup truck was a $700 million project. In 1977 dollars, in 2022 dollars, that's $3.4 billion. And why so expensive? Well, tooling. You can't just, if you're making million vehicles, and we were, because this isn't just trucks, it's the vans, I think Broncos, if we still made those, they all got this instrument panel. You can't just cut one tool, because you're making a million of them, and plastic takes a long time to cool off and solidify, so you got to cut multiple tools, and those tools are hundreds of thousands of dollars each. Then the new sheet metal, that's a massive expense. So all the engineers, here's the org chart, where this is just, let me look, it was just body sealing, climate control, and electrical department. And here's Paul way back then, kind of a freaky, long hair and beard. They didn't like me very much because I had a bad attitude. So it was a huge program, and 19 assembly plants were making trucks. So this is a massive design effort and configuration management, what you change, how you change it. So that was a context of this stylist thing of, oh, we're going to have such a pretty thing. Another factor is, because trucks had gone high volume, it was the biggest volume product in Ford, it had gone from the kind of, oh, those are truck guys, you know, kind of working class, we don't like them. Now we were the glamour guys. So the engineers, we didn't change much, but the top management, they brought over James A. Capilongo from the, I think, Thunderbird division. He was a car guy. And he made his first dictate for this truck was no exposed screws in the interior. Because, you know, that's not pretty, that's not, you know, sexy or whatever he thought it was. And we tell him, it's like, no, this is trucks. The guys, gals, they really like seeing the screws. They know how to take it apart. They know how to work on it. It didn't matter. So he insisted on that. First rough road course, all the parts fall in. So a new redesign, more setbacks, more expense to get this plastic panel going, okay? So let's go over the disaster as it unfolded, all right? Okay, so here's the 1980 Ford light truck instrument panel. Can you see it? Let me stretch it out here. So you can see how complex it is. And it spans the entire truck from door to door. It's incredibly detailed, very expensive, lots of weight. So that was the big cool thing we were going to do for the 1980 pickup. All right, first problem, right out of the mold. They assemble the door, which is all, used to be steel, now it's plastic. They assembled the door to the panel, and the stylist made a mistake. They did what you call a reveal, where there's a sharp edge and then the edge of the glove box door. So you could see, like this picture here, this is an eBay part, you can see the gap is not uniform. Because it's plastic and it cools off and warps a little, we couldn't control it. So, you know, they tried rubber bumpers, all kinds of stuff, so they got that disaster. And understand, because this is such an expensive tool, they can't go in there and grind it and hack on it, right? They got to accept that and try as we could to control the glove box door fit. That was the first thing they saw. Okay, here's the panel from the back, okay? So you can see this is an incredibly complicated tool to make. So expensive, maybe some slides so it can come apart after they mold it. You got to wait a long time. It's got a long cycle time. This is the terrible thing about plastics. That's why the Fiero failed. It takes so long to let the plastic cool off before you can pull it out of the mold and use it. So you got to have multiple tools because this is a slow operation. It's not like steel where you just bang it out. So Here's the first issue, and this was my problem because I was the truck engineer working. I pointed out that whoever made the assumptions 5 years ago forgot that this plastic panel, you don't get free grounding for the switches, the radios, the cigarette lighter. And now we got to add all this wiring. And they're kind of calling me a jerk, but because maybe I had long hair and a beard. Hey, I didn't make the assumptions. And there was no continuity at Ford. They kept rotating middle managers over and moving them all over because nobody was going up. It was a stagnant company. So everybody's moving around. So the guy that made those assumptions, he's 3 managers away, right? He's long gone. But I remember design costs for an 18-gauge wire back then, penny a wire, penny a foot, and a penny a termination for the pins on the end. So the cigarette lighter was even bigger gauge, even more expensive. So now all of a sudden the cost reduction is getting more like close to cost parity. And I was a jerk, I know this personally. So this is a known fact, the problem that we had. We changed the wiring harness, big tear up, get all that redesigned. Still haven't built this thing yet. And then we get to the next problem. Okay, the next problem is structural problem. We told them, the engineers told all the stylists and MBAs and product planners and finance wizards, this is a truck. It has its own durability course. There was an engineer in the test department, still remember him, Crash Krushka. His name was Phil Krushka, and he was so brutal on the test track, we called him Crash. He once took a truck over the Belgian blocks, the rough thing, he lost the filling. That's how dedicated this guy was to finding problems. These were the real heroes of Ford that nobody listened to. Design engineers were supposed to be high-tone. He was a test guy, so we'd say, oh, that wasn't a representative test, and the parts weren't quite made to design intent. Find all these excuses. But they were the first group that said, this panel's just flopping all over. It looks like hell. We can't have this. So you can see, here's here's a 1967, panel. Here's a 1979 panel. You can just see the metal structure, right? It actually increases the structure of the cab because it spans from door to door and increases torsional rigidity, increases the rigidity of the bottom of the windshield because it's got all this metal structure now. All that's gone. It's a big hole now with just plastic, with no screws because Mr. Capilongo, remember? So now the body group had to add metal braces. I remember there was like 2 down by the brake and clutch pedal support. There was another here. Now here's a picture. I'm not sure if this was original design intent or something that they had to add because of this problem. But you can see the metal plate where the radio mounts. Because guess what? The radio is big and heavy. So when Crash Krushka takes it over the Belgian blocks, that really snaps that radio and tries to break it out of the panel. So maybe they were aware of that, and this was original design, I can't tell you. But I wasn't in the body group. But they have this metal plate in there. So now the cost is pretty much a wash. Plus you got the assembly division mad at you because you got all these little brackets, and some of them are what we call a blind shot, where you can't even see the screw. They just got to kind of feel up there and zing, run it in, right? So now we've gone from cost savings to appearance problem, cost wash. But at least it's a wash, right? Okay. So just when you think it was bad, the real disaster happens. It took time, right? We had to get the appearance problem fixed. I had to figure out, we got to change all the wiring. So we get the wiring. We get it in a truck on Belgian block. We get it on reliability. Oh, it's falling apart. Add braces. So now it's ready for its first crash test, 35 miles an hour, full frontal, into a barrier. The dummy, which has foam to simulate human skin, of course, being Ford, they made it cheap. So it's an acrylic plastic, which was the cheapest plastic. And it was also have good sharp edges. It molded well, and you could hot stamp it with chrome, chrome plating, put phony chrome on it. So what would happen is in the 35-mile crash, the dummy would shatter the plastic, the head, and of course you can imagine this is the passenger, right? Head would go through, and then on the way out, it would rip your face off. This was not well received, right? So what are we going to do? Now, you could say, well, it's the person's fault. They didn't wear a seatbelt. But that doesn't wash. You'll still get sued. So the solution was to change the material. Now, I thought we went to polycarbonate, that's what they make the taillights that they whack with a hammer and show you. It might have been ABS, or it might be a blend. You can actually blend them in any percentage you want. But ABS is what they use in football helmets, right? So they just changed the material, got those prototypes in, put it all together, got my wiring harness in, ran a crash test. Then the crash dummy, because the panel is now so much stronger with this polycarbonate or ABS, the dummy hits, and that's great, it doesn't shatter, but it bounces the dummy's head back and breaks its neck, because they can evaluate that. That's why it's a crash test dummy. Now, all this is, I knew about the electrical issues. I can guarantee you that's, honest truth. All this other stuff is gossip, but I'm pretty sure it's true, okay? What we felt as cynical kind of engineers is that the lawyers, because engineers had nothing to do with the design of the truck. I thought we designed trucks. No. MBAs, finance wizards, lawyers, everybody but us designed the truck. So we feel that what the lawyer's calculation was is, okay, if it's polycarbonate, breaks the guy's neck, he's dead, maybe we get sued, maybe we don't. We blame him because he didn't have a seatbelt on. Send out a few bucks. However, if we leave it cheap acrylic and it smashes and rips his face off, now the guy's alive, but his face is ripped off, and you get him in front of a jury with his messed up face, and that's going to be a big award. That was our theory, at least. So now they switched, and boy, oh boy, I think polycarbonate was almost double. So now, and when you make big volumes, the first time I went to cost estimating with a taillight, he put it on a scale, looked up the price of ABS and polycarbonate, did some math and said, okay, it's $7, design cost, our cost, not your cost. Multiply times 10 to get what you pay for it, or times 20 if you buy it as a service part. But when you make that many, the cost of the tool gets amortized to just a few pennies, right? Because you're making so many of them. So the weight of the plastic is a primary driver of the cost. And now we've changed from an acrylic, cheap, to a polycarbonate or ABS or a blend, expensive. It could be as bad as twice as expensive. Now the cost benefit just sails out the window. But see, it's too late. The tool is cut, the project's moving forward, the sheet metal's all cut, all that works together, right? The plastic dash and the cab. So, just eat the cost. And that's what they had to do. And that's maybe why I think this ran till 86 or maybe even 87. And I remember the project as being a 5-year run. So maybe they added that extra year to pay a little bit more profit to offset this huge cost that we incurred with this stylist-inspired, let's be like Chevrolet plastic dashboard. Okay, here's the sad irony. What is good? What is the best for crash? Without a seatbelt, if your head's going to hit that dashboard. It's actually what we had in 1979. A steel panel with a foam pad. The foam pad kind of cushions and keeps you from breaking your skull. The steel bends. I know it sounds extreme, but in a 35-mile-an-hour crash, your head will bend that dashboard, but that absorbs the energy, so you don't get that snap back, just like breaking the plastic did. But now you don't have shards of steel ripping your face off, so that would have been the best crash protection. But see, it looked old, it wasn't pretty, and I can't really criticize for it. Back then, I was Mr. Bitter, right? This is ridiculous. But now I understand, right? I had an executive when I worked at GMC Truck and Coach. I complained about planned obsolescence. We change every year, and he got the numbers out. Here's a Chevrolet Impala sales. We change the front end, do a minor uplift, sell more cars. Here's a major redesign, sell way more cars. So I can't blame them, but I still to this day think there would have been a better way. Maybe keep the steel structure. I don't know. Make the foam more like a RIM, reaction injection molded foam, where you could have more features and pretty on it and still have the steel underneath for strength. Best of both worlds. I don't know. But that was the disaster. What was booked as a cost savings, but was really a stylist's, make it pretty product planner deal. It was booked as a cost savings and sold to management as a cost savings, ended up being a cost penalty, a durability penalty because they shook, an appearance penalty because it had that reveal on the glove box door, and a safety penalty because it would kill you instead of maim you. So that's some system engineering, and that's why it's so hard. And I hope you enjoy this. I'm going to be doing a whole series. Every day I'm going to be coming up with a new story about, in my career, engineering things. There's going to be a whole bunch of Ford ones, and then all the different companies I worked at, problems, hopefully to teach you so you don't make the same mistake as Ford Motor did in 1980. All right, Sportster Paul, catch you next time. Thanks for watching.